Okay, let's jump right into this. Welcome back to The Explainer. Today we're tackling a pretty wild question. What actually happens when a foundational, absolutely legendary piece of computing architecture just retires? We're looking at a monumental shift in the world of computer science today, one that closes the book on literally decades of history and opens up a fascinating new chapter.
To really grasp the gravity of this shift, we've got to talk about MIPS. This is a name that seriously echoes through the halls of computer science. For decades, it was basically the invisible engine powering a massive chunk of our digital world. Every time you used a network router, booted up a classic gaming console, or tinkered with an embedded system, there was a very, very high chance MIPS was grinding away behind the scenes. But then, in March 2021, the industry got hit with a shocking pivot. To understand why that happened and what it actually means for the tech you use every day, we need to rewind a bit.
Section 1. The birth of MIPS, a foundation of modern computing.
So, developed right here in the US by what we now know as MIPS technologies, this pioneering architecture was built to solve a massive problem in computing efficiency. And honestly, they nailed it. MIPS actually stands for Microprocessor Without Interlocked Pipeline Stages, which I know sounds like a mouthful, right? But in plain English, it's a core family of RISC architectures. RISC meaning Reduced Instruction Set Computer. The whole philosophy here was about streamlining. It was about giving a processor simpler, highly optimized instructions so it could execute them lightning fast, instead of bogging the hardware down with these heavy, multi-step commands. It was a totally revolutionary way to get way more performance out of less silicon.
Moving on to Section 2. Technical evolution. From 32-bit roots to Release 6.
Look, here's the reality of the tech industry. You either evolve to meet the times, or you become completely obsolete. MIPS chose to evolve. In its early days, the architecture was strictly 32-bit, which was totally fine back then. But as software got hungrier and data streams just exploded in size, engineers needed more bandwidth, so they built robust 64-bit versions. This constant, steady refinement led all the way up to April 2017, when they rolled out MIPS 32 and 64 Release 6. But this decades-long journey of internal evolution eventually hit a wall, or rather, a historic milestone, in March 2021, which we're going to unpack in just a second.
The real turning point in this evolution was the massive technical shift between the older and newer versions. The early iterations, like MIPS I through V, were fundamentally built around a user mode architecture. They were great, but kind of limited in their system-level scope. But the jump to the MIPS 32 and 64 generations, that was huge. They evolved way beyond that basic design by adding a defined, privileged kernel mode system control coprocessor. Basically, it gave the processor way deeper, much more secure control over the system's hardware. It meant MIPS can now handle advanced operating systems and super complex memory management without breaking a sweat.
Section 3. Powerful Architecture Extensions. Adaptability in action.
The reason MIPS stayed so incredibly relevant for so long wasn't just its solid core design. It was its extreme adaptability. They used a suite of really powerful optional hardware extensions that let engineers customize the processor for highly specific tasks. Like need to render graphics? You had MIPS 3D handling complex floating point stuff. Doing heavy math? NDMX stepped in for 64-bit integers. If you were building a tiny embedded device where memory was at an absolute premium, MIPS 16E added instruction compression to save that vital space. And for heavy multitasking, MIPS MT brought dedicated multi-threading to the table. They literally had a perfectly engineered tool for every major computing challenge you could throw at them.
Section 4. A Lasting Legacy, From Classrooms to Silicon.
Now, the story of MIPS isn't just about commercial silicon powering routers or your old game consoles. It actually became the absolute gold standard for computer architecture courses in universities all over the world. Because the instruction set was so beautifully clean, logical, and structured, it became the quintessential textbook example. It was literally the baseline used to train entire generations of modern software and hardware engineers on how computers actually tick at the processor level.
And because all those engineers cut their teeth on MIPS, its influence has been permanently baked into the industry. It profoundly influenced almost all later RISC architectures, shaping the DNA of subsequent powerhouse systems. I mean, it paved the way for legendary architectures like DEC Alpha. Even if a modern microchip doesn't have the MIPS logo stamped on it today, its core design philosophies, its whole approach to pipelining and handling instructions, are absolutely carrying that MIPS legacy forward.
Finally, Section 5. The Pivot to RISC-V, Passing the Baton.
So how do you gracefully retire a legend? Well, you don't call it a failure, you frame it as a strategic evolution. That historic leap happened in March of 2021 when MIPS dropped an absolute bombshell on the tech community. They announced that the development of the venerable MIPS architecture had officially come to an end. After decades of nonstop innovation, the timeline was finally drawing to a close.
But here is the brilliant part. They weren't just closing up shop. Instead of fading into obscurity, MIPS announced they were transitioning entirely to RISC-V. They looked at the tech landscape and realized that the open-source, highly collaborative nature of RISC-V was the undeniable future of computing. So they packed up their decades of hard-won expertise and dedicated the company's entire future to this new open standard. They chose to contribute to an ecosystem where anyone can innovate, completely free from the lock-in of proprietary licenses.
Which brings us to the big question to wrap up this explainer. With a giant like MIPS officially stepping aside and throwing its full weight behind this new open-source standard, is RISC-V now the undisputed future of CPU architecture? I mean, when the teachers themselves become the students of a new technology, you know a massive paradigm shift has arrived. It's going to be fascinating to watch this play out. Thanks for hanging out with me for this deep dive. Keep questioning, keep learning, and I'll catch